Hello friends, today we are going to revise what we have seen in thermodynamics. So the chapter that is named as Thermodynamics. So revision of some parts what we have seen in last few videos. We have to revise first one and then we are going to proceed further the next point of this chapter. So already we know that the thermodynamics means the conversion of heat energy into dynamics, that is mechanical energy. So heat is converted into mechanical energy and mechanical energy may be converted into heat energy. So this is our aim, that you have to perform some work, then that work should produce heat. If you provide heat to certain system, then it is expected to do some work. So this is our aim to study the thermodynamics. To study the conversion of heat energy into work and work into heat energy, we need certain concepts. So first concept we have seen, that is known as the system. What is system? System is a part of isolated part of this universe, whole universe. Whole universe consists of large number of energy, large heat, and these heat may be converted into work into heat, different forms. What we are going to concentrate on one certain thing, one certain material, one certain, that is the state of certain object on which we are testing the conversion of heat energy into work into heat energy. That isolated part of system, isolated part of surrounding, it is called as the system. This system, when you consider, then that is nothing but the space around it, which consists, that is the different things. Let's say myself is considered as a system. Then in this room, this board is my surrounding. The space around this room, in the room, is my surrounding. Because all these things may sometimes impact on this system. Suppose here we are going to on the AC. That means this room becomes colder. When room becomes colder and colder, my body is also becomes colder. That means the room environment affect me. So that means system get changed into one point, that is the heat is exchanged between system and surrounding. So that means here the thermodynamics comes in act. So we have understood this is the isolated part of the system. Then the surrounding means what? Surrounding means the space around the system. That is the surrounding which impact on the system. Then that is the boundary between system and surrounding is also once again known as the boundary, which separates the system and surrounding. That is nothing but boundary. So this boundary, there are two types of boundary we have already studied. That is one diathermic and second is known as adiabatic. So we have taken two examples. Here are the two examples. One is a plastic bottle. This is considered as a system consisting the water and anything. That means here it also contains air. Then the space around this is the surrounding. this plastic act as a boundary. When the air around this is hot, then this bottle, that is the liquid or the solid or the gas in this the system also changes its that is the state. This is diathermic bottle because here there is exchange of heat energy with respect to surrounding. But as we consider this is a thermos, this most of the times it will not exchange its heat to the surrounding and also do not accept the heat from the surrounding. That is, it is adiabatic boundary. So two types of boundaries we have already seen. Then we have seen the energy exchange. Energy exchange. Due to energy exchange, there will be a state of the system changes. There will be a state of the system changes. So what is the state of the system? System as a whole. So consider this is the system as a whole. If this system consists now of air, but when I will add the water in this, then the system remains constant. System remains same, but its state changes because the amount of air, pressure inside, temperature, volume may get changed, and therefore the state of this system is going to change. The state of this system depends upon the state variables. State variables. So any state, any system is characterized by the thermodynamic state. This state will also characterized by thermodynamic variables. So already we know that there are two types of variables. The one it is called as intensive variable and another is called as extensive variable. Intensive variable, we know that what do you mean by intensive variable? What is nothing but extensive variable. Next, we have seen when there is a change in energy, state variable changes, there will be a change in energy. That means energy exchange takes place. When energy exchange takes place, then there is a change in its internal energy. So we have studied the internal energy. What do you mean by internal energy? Already we have known that in a system, for the simplicity, we have to consider one, that is the cylinder. As a simple form, we are going to see this is not always the thermodynamic system, but we are supposing that this is a thermodynamic system. My sample is also the thermodynamic system. Anything in this room is also thermodynamic system. But to study well, we are going to consider this is a thermodynamic system, which consists of gas. Gas consists large number of molecules. Similarly, myself also consists large number of molecules or particles, we may say, cells and other things. And when the energy will change, energy of this state is changed, then its internal energy changes. So already we have supposed that the system may be diatomic, monoatomic, triatomic, like this. That means the monoatomic means H, hydrogen gas, H2, O2, then CO2. These are the triatomic gas. These are the diatomic gas. This is the single atomic gas. So when each molecule is moving in different directions, they have some kinetic energy. That kinetic energy, summation of all kinetic energy gives rise to internal energy. There are three types of the kinetic energy we have studied. That is the kinetic energy, that is translational, kinetic energy rotational, and kinetic energy, that is vibration. So as all the molecules are moving and vibrating, the potential energy is supposed to be 0 for a closed system. So these are the summation of all these three energies gives rise to internal energy. Internal energy. So this internal energy is denoted by U. Then there is exchange of internal energy. Internal energy as well as heat energy and work. So now we have first of all differentiated the that is called as the heat, then internal energy, and then the work. So these are all the forms of energy. Heat is one type of energy which is in transit mode, that means which is flowing. Internal energy is the energy which is in static mode, and the work is in mechanical form. Mechanical form. So that means all these, that is heat, internal energy and work, are nothing but the type of energy. All these energies are measured in terms of Joule. Heat is in transit, internal energy in static, and work is in mechanical. So now, the internal energy, when we focus on the internal energy, then total energy becomes the internal energy. Total energy of the system, this total system is known as internal energy. Sum of all type of energy, this system may consist, that energy is called internal energy. So this system consists large number of molecules. The average kinetic energy average is called as the temperature. So temperature is the thing, but average, some molecules are moving fast, some molecules are moving slower, some molecules are, that means different direction, that is the velocities in different directions, that means they have some more and less kinetic energies. So you take the average of each molecule, then that average kinetic energy is measured in terms of temperature. So temperature is measure of the average kinetic energy. Total energy is internal energy. Is it? So now when we are going to suppose that there is a higher temperature, if you put thermometer, then this thermometer shows certain temperature. When we consider two systems, that means system 1 and the another system, that is, this is system 2, and also this system consists another thermometer, suppose, and these two systems are joined together by certain openings. There is flow of heat from higher temperature to lower temperature. There is flow of heat from, not from lower temperature to higher temperature. Suppose this is temperature T1, this is temperature T2. If T1 is greater than T2, then automatically there is flow of temperature. This flow of temperature continues till that T1 must be equal to T2. T1 must be equal to T2. So this process, that means the flow of energy from higher temperature region to lower temperature region, gives rise to the zeroth law of thermodynamics. Zeroth law of thermodynamics. So we have differentiated in heat, internal energy, work and temperature. Then temperature is the average kinetic energy. If temperature of certain material is higher, then its heat energy is higher, its internal energy is higher, it has capable to do work. It has capable to do work because it has energy. So then if we join to another system which is at lower temperature, lower energy, lower heat, then the heat flow from, naturally heat flow from higher to lower. So that gives rise to zeroth law of thermodynamics. What it states? It considers three states A, B and C. Then if A is in thermodynamic equilibrium with C, suppose this is T1, this is T2, this is T3. Suppose that T1 is equal to T3, T2 is equal to T3, that means the temperature of that the A is equal to temperature of T, that means A system or A state of the system is in equilibrium with C, that means T1 is equal to T2. B is thermal equilibrium with C, this is second state. Then automatically, according to zeroth law of thermodynamics, states that this A and B are also mutually in thermodynamic equilibrium with each other. So this is the zeroth law of thermodynamics. So these are the points we have discussed. One more point we are going to discuss is the first law of thermodynamics. First law of thermodynamics. What this first law states? If we consider a system, for detail you can see the particular video of first law of thermodynamics. I will explain here the point just as a revision. So if you provide certain amount of heat, dQ is amount of heat provided. This dQ amount of heat changes its internal energy, and also there is some work done by the system or on the system, maybe reversely. Then there is a relation between, this is delta W you can see. Then there is a relation between heat provided, change in internal energy and change in work. So that relation is given by du is equal to dq minus dq, or you may say delta q, and plus delta w. So this relation is called as the first law of thermodynamics. What it gives? Change in internal energy is due to change in the external energy provided either by doing work or providing heat. So this change in internal energy of the system is given by first law of thermodynamics. So all these things then comes to one point, that system as a whole, which is characterized by its state, and state is characterized by its variable. State is characterized by its variable. Then we are going to change one state to another state. We are going to change one state to another state. Then there is a process that is called as the thermodynamic process. So if all the students can understand up to this point, that means system, surrounding, state, then the energy exchange, state, then the difference between heat, internal energy, work, then the zeroth law of thermodynamics, first law of thermodynamics. Then we are going to see the next point in this video, that is the thermodynamic process. So what is the thermodynamic process? Suppose for that condition, once again we are going to suppose one simplest model of gas in a cylinder. This is a thermodynamic system. This thermodynamic system is characterized by the state A, and the state variables of this state is, suppose this is P1, volume V1 and temperature T. If we change any one variable, if we change any one variable, then state changes from the state A to state B. State A to state B. These are called as state variables. Generally, there are 4 state variables. We can assume that the 4 state variables P1, P1, T1 and S1. Where P1 is the pressure, P1 is the volume, T1 is the temperature and S1 is the entropy. Entropy means the disorder of the system. We can see the details study of entropy in the last video of this thermodynamics chapter. So when we change the state, any one variable changes, automatically other variables may change and sometimes may not be changed. But when any one variable changes of this state, then the state changes from one state to another state. Suppose we can change that P2, V2, T2 and S2 are the state variables of D. If this state is changed from one state to another state, and each and every step is very slow, this state is in a thermodynamic equilibrium with the surrounding. Each step is known. Each step is very slow and each step is known. Then this change of one state to other state is called as the thermodynamic process. What do you mean by thermodynamic process? That if one state changes from one state to another state, we may suppose that it is initial state, and this is final state. Then each and every point in this is very, very slow. For example, we can say in general, very, very slow. You cannot identify that state is going to change. That means we suppose that example is a growing of hair. Growing of hair. Daily hair will grow. Daily these hair are growing. But we can't understand that this is growing. We can see that this hair is growing. But the growing of hair is very slow. And such type of the process in which there is exchange of energy in thermodynamic equilibrium, thermal equilibrium with the surrounding, then the process from this state to this process, this state to another state, is called as the quasi-static process. So what we are going to see? Thermodynamic process is the process in which one system, the state of one system changes to another state. Then this process is very slow. Each and every point is in thermodynamic equilibrium with the surrounding. Then that process is called as thermodynamic process. If the change in the state from initial state to final state is very, very slow, that means static means almost static, this word that is stable, that means you cannot understand that process is going on to change. Quasi means very slow. It is almost stable. It is very small change. Then this process is called as quasi-static process. So quasi-static process is denoted by the that is the thermodynamic variable, the graph of any two thermodynamic variables or state variables, then we can suppose that there is a one change between pressure and volume. Suppose this is a state A, which is indicated by T1 V1, and this state goes to state B, T2 V2. This state A changes to state B. We have plotted the graph of this, that is change in pressure and volume, change in pressure and volume. So what this graph shows, that this graph indicates how the pressure and volume changes. So in this state, that is this process, each and every point we know the volume of the gas, we know the pressure of the gas. Then we can represent the graph of P versus V. So this graph is known as indicator diagram. This graph is known as indicator diagram. Many times students do not understand that indicator diagram is only the graph of P versus V, but it is not true. The indicator diagram may be the graph between temperature and entropy. That may be temperature and entropy, temperature and pressure, temperature and volume, volume and entropy. So that means you can represent this, that the variation of state from one to another by a graph. That line indicates how the system changes, how the state changes. Then this graph is called as indicator diagram. Now, already we have studied the state changes from A to B. So there are four state variables. State variables are pressure, volume, temperature and entropy. So accordingly, there are the four thermodynamic processes. One, it is called as, that process is called as isobaric change. That means the isobaric change, we can represent like isobaric change. So when state A changes to state B, its state variable changes from this to this. But during the change, if pressure remains constant, but V1 changes to V2, T1 changes to T2, S1 changes to S2, but the pressure remains constant. Pressure remains constant. Then the process is known as the isobaric process or isobaric change. The change is known as isobaric change. So what is the isobaric? The state, one state changes to another state at constant pressure. Then that change is called as isobaric change. Second stage is isochoric change or isochoric process. In this, what will happen? Pressure may get changed, but volume remains constant. Volume remains constant. Pressure changes P1 to P2, temperature changes T1 to T2, entropy changes S1 to S2, but temperature does not change. Volume does not change. That means volume remains constant. Volume is constant. So the thermodynamic process, in which the system state changes from one state to another state at constant volume, then we can say that that change is isochoric change. Next is isothermal. You all of you know that. isothermal change. So here what will happen? P1 changes to P2, P1 changes to V2, but T1 remains constant. T1 doesn't change, but S1 and it changes to S2. That means here in this process the temperature remains constant. So we can define the isothermal process or isothermal change is the thermodynamic process in which the state variable or state changes from initial to final at constant temperature, then it is called as isothermal change. Last one is adiabatic change. In this adiabatic change, the what remains constant? P1 changes to P2, P1 changes to V2, P1 also changes to T2, but the entropy of the system, entropy of the state remains constant. Entropy, so you can write here, entropy is constant. So this change is called as the adiabatic change, or the process is called as the adiabatic process. So can you define the adiabatic process? That is, it is the thermodynamic process in which the system changes from state A to state B at constant entropy. What do you mean by constant entropy? There is no exchange of heat energy. So heat neither be added to this system nor be taken outside the system. So that means the entropy of the system remains constant. This is known as the adiabatic change. So what we have studied in this video is the thermodynamic process. Thermodynamic process is the process in which the system or any system having state A changes to state B. That means we have already indicated one like this. So this is the system, this is the system, and it has having state A. Suppose this is state A, having small amount of quantity of water. If some quantity of water is taken from it, suppose I already showed this, some quantity is taken, its volume changes, pressure changes, temperature changes, and also entropy changes. So this state change from A to B, then this is called as thermodynamic process. So due to exchange of energy, due to exchange of amount of air, that is the material molecules, also the state changes from one to another. Then there are different types of the changes. So already we know what is quasi-static. Quasi-static is very slow process in which every step is known. The graph of any two variables of a state from changing state A to state B is indicated by a graph. Then that graph is called as indicator diagram. That may be graph between P and V, P and T, P and S, P and T, P and S, and so on. Then there are four types. The isobaric change where pressure remains constant, isoporic change where volume remains constant, isothermal change where temperature remains constant, and adiabatic change, entropy remains constant. So what we are doing here, that we are converging the heat into work. Work is nothing but mechanical energy. Work is nothing but mechanical energy. So heat given to the system, it does work. If we press this one, then it can produce the heat. So that means interconversion of heat energy into temperature or heat energy into mechanical work. This chapter is known as thermodynamics. And we are going to study the step by step, the variations, step by steps, concepts of thermodynamics. And in this video, we have clarified what do you mean by thermodynamic process. Okay, thank you.